To understand how chat changed the world, we first need to look at how computers traditionally struggled with human language. For a long time, computers were amazing at math and calculations, but they were completely lost when it came to normal conversation. Back in the 20th century, the famous scientist Alan Turing created a simple test. If a computer could text with a human and fool them into thinking it was also a person, then the machine could be called intelligent. This became known as the Turing test, and for decades, it felt completely impossible. Early computers were incredibly rigid, operating on strict and changing rules written by human programmers. If you typed a command perfectly, the computer executed it, but if you made a single typo, or if you used a creative metaphor, the system completely choked. Early chat programs like Eliza in the 1960s tried to trick people by mimicking a therapist, using simple tricks like turning your own questions back on you. But the illusion vanished the second you tried to have a genuine, spontaneous conversation. Human language is simply too messy, emotional, fluid, and full of unspoken context to be captured by regular coding rules. The real turning point that set the stage for a new era happened in December 2015 in the tech-heavy city of San Francisco, California. A unique group of wealthy tech visionaries, investors, and elite scientists decided that the traditional way of developing artificial intelligence was too slow and too secretive. This group, which included names like Sam Altman, Elon Musk, Ilya Sutskever, Wojciech Zaremba, and Greg Brockman, came together to establish a brand new research laboratory called OpenAI. They started the organization with a highly idealistic and deeply ambitious mission as a nonprofit entity. They believed that artificial general intelligence, a type of AI that could match or exceed human intelligence across the board, was not a matter of if, but when. Because this technology would be so incredibly powerful, they feared that if it were developed in secret by massive, profit-driven tech monopolies, it could lead to extreme global inequality or even dangerous, uncontrollable systems. They wanted to create an open, collaborative environment where the world's best minds could work together to ensure that advanced AI would benefit every single human being on the planet. The early days at OpenAI felt like a wild, chaotic academic startup. The office was filled with whiteboards, running computers, and intense late-night debates. Interestingly, the team didn't start out by trying to build a conversational chatbot. Instead, they spent years focusing on robotics and reinforcement learning, which is a method of teaching computers through trial and error. They built AI software that learned how to control robotic hands and agents that played complex video games like Dota 2. They would let these digital minds play against themselves millions of times, practicing at hyperspeed. Over time, the researchers watched in amazement as the AI developed brilliant, highly creative strategies that no human programmer had ever taught it. This early success proved a vital theory: if you give a neural network the right architecture and let it practice on enough data, it will naturally develop emergent abilities that surprise even its creators. However, the world of human language was still an unsolved riddle, and the team knew they needed a completely new kind of mathematical engine to bridge the gap between numbers and human speech. Act 2. The secret engine of the revolution. Ultimate breakthrough that unlocked the future of artificial intelligence didn't actually happen inside OpenAI. It came from their rivals at Google in 2017. A team of Google scientists published a legendary research paper with the catchy title, "Attention is All You Need." This paper introduced a completely radical new blueprint for processing data called the transformer architecture. Before this invention, computers read text the exact same way humans do, word by word, from left to right. If a computer was processing a long sentence, it would look at the first word, then the second, then the third. The massive flaw with this approach was that computers have a very short attention span when reading sequentially. By the time the software reached the end of a long paragraph, the mathematical representation of the words at the very beginning had faded away completely. Furthermore, reading word by word meant that the work couldn't be split up easily across multiple computer chips, making the training process incredibly slow and frustratingly expensive. The transformer architecture changed the rules of the game overnight by allowing a computer to process entire documents all at once, in parallel. It achieved this through a brilliant mathematical trick called the self-attention mechanism. Instead of reading sequentially, the transformer looks at every single word in a sentence simultaneously and calculates how much attention each word should pay to every other word around it. For instance, if a machine reads the sentence "the bank of the river was muddy," the self-attention mechanism immediately connects the word bank to the word river, instantly figuring out that the text is talking about geography and not a financial institution. If the sentence changes to "the bank approved the loan," the system shifts its attention to the word loan and realizes it is talking about money. When the researchers at OpenAI read this paper, they had a collective epiphany. They realized that the transformer was the missing piece of the puzzle they had been hunting for. They immediately abandoned their work on robotics and other old code and pivoted their entire corporate strategy toward building massive transformer-based language models. This decision marked the birth of the generative pre-trained transformer lineage, which the world now knows simply as GPT. In 2018, they built GPT-1, a relatively small model with 117 million internal connections, or parameters. It was an initial test, but it proved a monumental concept called unsupervised pre-training. It showed that if you simply feed a transformer network a massive mountain of raw internet text and force it to play a giant game of fill-in-the-blank, guessing the next word in a sentence over and over again, it will naturally learn the rules of human grammar, logic, and facts about our world without any human teacher guiding it. Empowered by this discovery, OpenAI decided to scale up the technology drastically. In early 2019, they created GPT-2, which was over 10 times larger, boasting 1.5 billion parameters. The text generated by GPT-2 was so shockingly realistic, fluent, and coherent that OpenAI actually panicked. They made the controversial decision to lock the full model away from the public for several months, releasing a statement that they were terrified malicious actors could use it to generate automated fake news, political propaganda, and internet scam messages at an industrial scale. This move sparked intense global debates about scientific censorship, but it also proved that OpenAI had captured lightning in a bottle. By the time 2020 arrived, the organization realized that to build even bigger models, they needed a mind-boggling amount of money and computing power that a traditional nonprofit simply couldn't afford. They shifted their structure into a capped profit company and formed a massive, historic partnership with Microsoft. Microsoft invested billions of dollars into OpenAI and constructed a custom, giant supercomputer packed with tens of thousands of cutting-edge graphics cards linked together by high-speed networks. With this ultimate technological weapon at their disposal, OpenAI trained GPT-3 in the summer of 2020. This model was a true titan, featuring 175 billion parameters. It shocked the entire technology industry because it didn't just write simple sentences, it could draft entire essays, write functional computer code in multiple programming languages, translate between idioms, and mimic the specific voices of historical figures with an eerie accuracy that many experts believed was still decades away. Act 3: Taming the Wild Predictor. Despite the jaw-dropping brilliance of GPT-3, it was still a deeply flawed, unpredictable, and highly untamed beast. You have to remember that at this stage, the model was fundamentally just a superpowered autocomplete engine. It was trained to look at a string of words and guess what words naturally follow on the internet. Because the internet contains a massive mix of brilliant academic papers, casual conversations, toxic arguments, and absolute garbage, the raw GPT-3 model reflected all of that chaos. If a user typed a question into the raw model, it wouldn't necessarily answer it. For example, if you typed "write a story about a doctor," it might decide that the next logical text on the internet would be a medical bill or a list of hospital addresses. So it would just generate that instead. Even worse, if you asked it a question it didn't know the answer to, it wouldn't admit its ignorance. Instead, because its only job was to sound plausible, it would confidently invent completely fake historical facts, fake scientific studies, and fake statistics with absolute confidence. Computer scientists gave this frustrating and dangerous habit a specific name: hallucination. If a user gave the model a dark, biased, or malicious prompt, the system would happily generate highly toxic content, bomb-making instructions, or hate speech without a single second thought. Because it had no moral compass, no concept of right and wrong, and no understanding of human safety. OpenAI quickly realized that a raw text predictor, no matter how intelligent it seemed, was far too wild and dangerous for the general public to use safely. They needed a way to tame the machine, to bend its brilliant mathematical capabilities to match human values, manners, and safety standards. To solve this monumental challenge, they developed a revolutionary training methodology known as reinforcement learning from human feedback. The process was fascinating and required a massive human effort. OpenAI hired large teams of human educators, writers, and specialists from various fields to sit down and have thousands of long, controlled conversations with the AI. The human trainers would give the model a prompt, and the model would generate several different potential answers. The humans would then meticulously review these answers and rank them from best to worst based on helpfulness, accuracy, politeness, and safety. If the AI tried to lie, hallucinate, or give dangerous advice, the humans gave it a low score. If it was honest, concise, and helpful, it received a high score. This massive dataset of human preferences was used to train a separate, secondary neural network called a reward model. This reward model essentially learned how to think like a human editor, understanding what humans consider good and bad behavior. Finally, OpenAI used an optimization algorithm called proximal policy optimization to run the main language model through a digital bootcamp. The main AI would practice generating millions of responses, and the reward model would instantly grade them, forcing the main AI to constantly adjust its internal mathematical weights. Through this intense training, the wild text predictor was successfully transformed into a polite, helpful, and disciplined digital assistant known as Instruct. The scientists hadn't just taught the machine how to predict words anymore. They had successfully taught it how to listen to human intent, respect boundaries, and follow instructions safely. Act 4, the day the world changed. Be the late autumn of 2022. The engineering teams at OpenAI had combined this advanced alignment training with a highly optimized, refined version of their core model, which they called GPT 3.5. Internally, the employees were using this conversational system every single day to write code, summarize long mails, and help them with their daily tasks. They found it incredibly useful, but the broader public still had no idea it existed, as accessing the model required technical knowledge of programming interfaces. The executive team, led by Sam Altman, made a spontaneous decision to build an incredibly simple, clean, and free web interface around the model. They wanted to create a user experience that looked exactly like a standard text messaging or chat application, something that an 8-year-old child or an 80-year-old grandparent could understand instantly without reading a manual. The project was put together rapidly in just a few weeks. Interestingly, there was a high degree of skepticism inside the company. Many top engineers and executives thought the chat app would be a modest, quiet research preview. They viewed it merely as a casual tool to gather real-world conversational data from the public so they could use those interactions to build their true next-generation model, GPT-4, down the road. There was absolutely no marketing campaign, no television commercials, no massive press releases, and no global media events. On November 30th, 2022, OpenAI quietly updated their website and launched chat by posting a simple public link on social media. What followed was a cultural, technological, and economic explosion that shook human civilization to its very core, catching even its own creators completely off guard. Within just 5 days of its quiet release, chat blew past 1 million users, a milestone that took Netflix 3 years and Facebook 10 months to achieve. Within 2 short months, it reached an active monthly user base of over 100 million people, shattering every single record in modern tech history to become the fastest-growing consumer software application ever created. The sheer, unprecedented velocity of its adoption caused absolute chaos behind the scenes at OpenAI, as their engineering teams had to work around the clock to prevent their servers from crashing under the weight of millions of people trying to log in at the exact same time. Suddenly, the entire world was staring at a flashing cursor on a clean white screen, watching a digital entity generate brilliant university-level essays, debug complex lines of software code, write beautiful wedding vows, create custom bedtime stories, and explain advanced quantum physics in simple terms within a matter of seconds. It was a true shift in human history. A massive panic swept through school systems and universities worldwide as educators realized their traditional essay assignments were instantly obsolete. Major corporations held emergency meetings to rewrite their entire 5-year business strategies, realizing that cognitive automation was no longer a future fantasy, but a present reality. The launch of Chat ignited a fierce, multi-billion-dollar corporate arms race among global technology giants, causing companies like Google to issue internal code red emergencies and scramble to build their own competing digital minds to survive in this new landscape. Act 5. Inside the digital brain. To truly understand the magic of chat and separate reality from science fiction, you have to look past the captivating illusion of a conscious mind and realize that beneath the user interface lies a colossal, beautifully designed engine of pure mathematics, statistics, and probability. Chat does not have feelings, it doesn't possess personal beliefs, it has no consciousness, and it has never experienced the physical world. It doesn't know what love feels like, and it doesn't know what water tastes like. Instead, it operates entirely on numbers. When you type a prompt into the chat box and press enter, your text goes through an initial clinical process called tokenization. The system uses a specialized algorithm to instantly chop your sentence into tiny, standardized computational fragments called tokens. A token isn't always a full word. It can be a single syllable, a prefix, or just a few letters depending on how common that specific sequence of characters is in human writing. Once your text is converted into a long sequence of token identification numbers, these numbers are transformed into mathematical vectors through an architectural component known as an embedding layer. This is where things get truly fascinating. Each token is mapped to a vector that consists of thousands of individual numbers, which essentially act as coordinates within a vast, high-dimensional mathematical map called a semantic space. In this digital galaxy of language, words do not have static dictionary definitions. Instead, their meaning is defined entirely by their spatial relationship to other words. Tokens that share similar concepts, emotional contexts, or grammatical roles are grouped tightly together. Because of this high-dimensional geometry, the system mathematically understands that the concept of a king relates to a queen in the exact same numerical proportion that a man relates to a woman, allowing it to grasp the deep, subtle nuances of human culture. Once these vectors are established, they travel through dozens of dense layers of the transformer neural network, passing through a continuous storm of matrix multiplications. In each layer, the self-attention mechanism calculates specific mathematical weights, allowing the system to track how words interact across the entire prompt. This is why if you write a very long story, and you mention a specific character's trait at the very beginning, ChatGPT still remembers and applies that trait appropriately when generating a sentence thousands of words later. Crucially, the final output of this entire computational pipeline is not a fully formed sentence or paragraph. ChatGPT constructs its responses autoregressively, meaning it writes one single token at a time. The network evaluates your original prompt and all the words it has written so far in the session, and it outputs a massive list of percentages representing a probability distribution across its entire vocabulary of tens of thousands of tokens. It asks itself a simple mathematical question, based on everything that has been typed so far: what is the most statistically likely token to come next in human language? The system selects a token based on this distribution, and you can actually control how it makes this choice using a setting called temperature. If you set the temperature to a very low value, the AI becomes incredibly strict, conservative, and factual, always picking the absolute safest, highest probability word, which is perfect for writing code or solving math problems. If you set the temperature to a high value, you introduce a controlled amount of mathematical randomness into the system, allowing it to choose less likely words from further down its list. To a human user, this looks like an explosion of genuine creativity, humor, poetic flair, and unexpected inspiration. Once a token is selected, it is immediately added to the history of the text, and the entire computational loop begins again, calculating the next word, and the next word, within milliseconds, creating the iconic visual effect of text streaming onto your screen with lifelike, fluid speed. Act 6, the next chapter and the human destineth viral explosion of the original chat was merely the opening act of an evolutionary story that continues to unfold at a breathtaking, almost terrifying pace. In March 2023, OpenAI reached another historic milestone with the public deployment of GPT-4. This new model was vastly larger and significantly more stable at complex reasoning tasks than the system that shook the world a few months prior. Most importantly, GPT-4 introduced true multimodality to the general public, meaning the artificial intelligence was no longer trapped in a world of pure text. It had finally been given eyes. Users could upload photographs, dense financial charts, handwritten medical notes, or even rough sketches drawn on a napkin, and the machine could analyze the visual data with the exact same level of fluency and deep understanding that it applied to written words. GPT-4 displayed an extraordinary capacity for advanced problem solving, easily passing the uniform bar exam to become a certified lawyer, scoring in the top percentiles of medical licensing examinations, and solving advanced academic competitions that leave most humans scratching their heads. Not stopping there, OpenAI continued to push the boundaries of user experience, eventually releasing GPT-4, an integrated omni model that brought real-time audio and emotional nuance into the ecosystem. This breakthrough allowed users to have voice conversations with Chat that featured absolutely zero perceptible lag. The AI could hear the specific tone of a user's voice, detect whether they were stressed, happy, or sarcastic, laugh at jokes spontaneously, and speak back with a highly expressive, realistic human voice that could change its pitch, speed, and emotional tone on command, making the software feel like a living science fiction companion. Today, Chat has successfully transitioned from a fun internet novelty into an essential, foundational pillar of global infrastructure. It powers international businesses, automates customer support channels worldwide, writes complex software code for programmers at lightning speed, and acts as a personalized, infinitely patient tutor for millions of students. However, this historic revolution has also brought human society to a complex and dangerous crossroads filled with profound ethical dilemmas. Acclaimed authors, famous musicians, and major news organizations have launched massive, multi-million-dollar lawsuits against AI companies, fiercely arguing that their proprietary, creative works were systematically scraped and exploited to train these commercial digital minds without explicit consent, proper attribution, or financial compensation. Labor economists are issuing urgent warnings about the unprecedented speed of economic disruption, noting that cognitive automation is rapidly impacting high-skilled white-collar professions that were once considered completely immune to automation, including software engineering, legal analysis, graphic design, and administrative management. Furthermore, intelligence agencies are terrified of the potential for automated disinformation, where malicious actors can use fine-tuned models to fabricate hyper-personalized political propaganda and flood digital communication channels with an untraceable volume of lies, threatening the core stability of democratic institutions globally. Beyond these immediate legal and societal battles lies the ultimate destination that OpenAI and the tech community are actively sprinting toward: the creation of artificial general intelligence, a hypothetical system that can outperform human beings at almost every single economically valuable task. As Chat continues to rapidly evolve, it forces humanity to look into a mirror and confront deep, uncomfortable philosophical questions. What does it truly mean to be creative? What does it mean to be intelligent? And how will human civilization navigate a future where we must share our planet with a digital intellect of our own creation that is changing the very fabric of reality forever?